Hello everyone. For this skip video, I would like to tell you about the new knowledges. We will call it a multiple integration. What does it mean of the multiple integration? We will have to separate the word. Multiple does mean double or triple, like this one or this one. This is very important for this our subjects because you need to apply all of this calculation to find the volume in the triple integration and the double integration for find the area in the regions that I will teach you in the another clip video. But for today, I would like to tell about how to calculate in the multiple integration. This have the principle that you have to understand and remind you together. What is the main point of multiple integration? So, multiple integration, for we will ask you in the first integration, we will have already the variables just only one, like this. You can see, if you would like to integrate it of the dx, you will get the x. If you cancel together. But in the multiple integration, we will have more variable, just like dx and dy. Does it mean you need to calculate inside? Then you will calculate outer, because you will do like a bracket. When you do in the bracket, you will do inside, and it's cover all of your calculation. Then this is our concept that we have to use for today. And then we will move to some example for you. It will raise to understand about the multiple integral, and you can apply to another examples or examination. Okay, we will start to the first. This one, I would like to ask you, what is the inside integral that you need to do first? Yes, this one. I will take a highlight here. This one is the integral that we need to do first. Then, when we get the value of the inside integral, then you put it on inside, and then do it the same, but we will get another of integral. We will call it outer integral. Okay, then we will start. Solution. Okay, first, we need to concern in this integral. This one is 2 and 1. And inside is the 4x cubed minus 4x squared multiplied by y squared dy. Okay, this is the yellow one that we need to consider. And then you look at this. We will respect to y. Then does it mean another variable in this equation? We will get this to the polynomial author's variable of y, author y. We will get it like a constant. Then you will look at this. 4x cubed. That means this whole thing is the constant. Then you can move out like this. When you put the dy multiply in both sides here, then you will get integrations of 2 and 1, and this one is 4x cubed. Then it's multiplied by dy. You will keep it dy here, and then you look at this minus 4x squared. This is a constant, but we have to y because we respect to y. Then we will move out just only 4x squared. Then integral of y squared dy. And then how to do next? This one is a constant. You can write it here. You see that this integral and this derivative of y is you cancel out, and it leaves only y. And don't be forget it about it, or integral. This upper bound is 2 and lower bound is 1. You will write like it and minus of 4x squared. Then this one we will get y squared will integrate will get greater than 1 and multiply 1. Then we got y to cube over 3. And don't forget the bounded up here. It is 2 and 1. That is part of calculation. 4x to the cube. This one we will instead y with 2 and subtract of the y equal to 1 is 2 minus 1 and then 4x squared of y cubed. That means 2 cubed. That will get 8 to number 3 and the subtraction with instead y with 1. It's 1 cubed, it's just only 1 the same. 3, yeah, and then you will get 4x cubed. This one just leave it only 1. And then it will get to 7 over 3 here. Use 8 square over 3 like this. And then you can answer here. Don't answer here because you don't forget to do the outer integral that you get inside. We will do next. Okay, right? We will need some spaces. Okay, we will copy all of the bounded up here and it respect to x. Here, 4x cubed minus 8x over 3 like this. And we will last step that we need to do. When this one will respect to x, that means x is a variable that we need to integrate. But some number in front of the variable, you can move it out because it's a constant. And we will do it separately, like this one. 4, 0 to 1, x cubed dx. Negative or 8 over 3 integral sorry for interrupted. Okay, and then this one is x squared dx and bounded is 1 and 0. Yeah, this one is 4 and inside you'll get x power 4 and over 4. This one is a 1 and 0. When you can see here, constant is the same, but it not change because we will consider to instead of 1 to 1 and 0. Okay, we can cancel 4 to get more easily. And then negative of 28 with 3, and then inside we will get of the 8 cube over 3. The bounded is 1 and 0. And then you can see this one will get 1 because we will take x equal to 1 and 2 power 4 is gets 1 and minus to the 0 is will get only 1. Then we will do is next 8 over 3. Then we will take inside this one is 1 over 3. And then in the 0 it cannot get someone if you get 0 and I didn't write in here. It's about 1 minus or 8 over 9 like this, and we will get this. Oh, sorry, 9. This 9, 8. This one you get minus 19 over 9, and this one is all for the multiple integration. For in the example A, we will get the answer is negative 19 over 9. And this one for the how to do in the concept If you understand the concept, you can apply to do another example. Let's see this example B. This one is a multiple integral, but then in the third with respect to r, and then respect to x. And how to do first? With respect to y, this means another variable will go to the constant. Then you look at this. It have x. X should be constant because with respect to y. Then we will move x out to integral here. And then we will rearrange new. It will get 0 to 1 and x's 1 and 2 is a y square root of x squared plus y squared dy dx. And then we will calculate in the inside of integration. Okay, first, integrations of 0 to 1 of y square root of x squared plus y squared dy. And then how to cope with it? You can see it have a choosing this multiple together, and then we would like to cancel out some term, and I would like to do a technique. We will call it a substitute. I will let u equal to x squared plus u squared du equal to, this is a be careful because x's you cannot get 2x dx because now with respect to y, then x is a constant. When the derivative of the constant, we will get a 0. And then derivative of y squared will get 2y dy. And then I would like to change dy to some term. It will get like this. dy equal to du over 2y. Then we change this one. It will get 0 to 1 of y square root u dy we get to du over 2y. Y cancel out and 1 half of 0 to 1 square root u du. It will increase the value of 1. It will get 1 over 2 plus 1 is u over 3 over 2. Then 3 and 2. We will cancel it out. And this one will 1 to 0. We will get 1 over 3. This one will get u power 2, 3 over 2, and the 1 and 2. But this step, you please remind you need to put the value of u back because in the bounded is not u, this is a y. And then 1 over 3 of x squared plus y squared 3 over 2 of this one. 1 and 2 is equal to, take y to 1 is plus 1 is half the square plus 1 3 2 minus of x squared of 3 over 2. Here you see here 2 and 2 will cancel it out. It just leave only 1 2 and 1 over 3. Inside you will get x squared plus 1 2 minus x to 3. This one is the inside. Then we will take it to the outer loop. This one, you will get it. This one is a constant. We will move out and just leave only multiply by x in the two term. You get x multiplied by x squared plus 1 over 3 power 3 over 2 minus x over to 4 dx. This one is the final step that we have to do. And then you look at here. This one is the layer in the first. We will substitute to let u equal to x squared plus 1 du equal to 2x dx. Derivative of 1 is 0 because these are theory, right? And then dx equal to du over 2x. Then we will have to do this separately. 1 over 3 integration 0 to 1 of x. We will let u inside u power to 3 over 2 dx is du over 2x and minus integrations 0 to 1 of x over to 4 dx. Then 1 over 3. And this one, you see, this one is cancel. Cancel together is leave just only 1 over 2 of integration u over 3 over 2 du minus this one is increase the power by 1 x over 5 2 over 5 this 1 and 0. Next 1 over 3 1 over 2. This one increase the value of this by 1. We will get u equal to 5 over 2 over 5 over 2. The bounded up here, okay, you don't forget this, 0 to 1. This one is a constant, you can cancel out. Minus, this one take x equal to 1. You get 1 over 5 and subtract with this x equal to 0 is minus 0 is get the same answer. Okay, this one will get 1 over 3 of u. We will take this one out. You see this one 5 and this one 5. You take this one to be 1 over 15. So this one is u 5 over 2 and 1 0 minus 1. Here. This one you need to put the value back. Thus we let u to be x squared plus 1. Then 15 2 square plus 1 and power by 5 over 2 and the bounded of this is 1 and 0 minus 1. Then we will move here is equal to 1 over 15. We will take x to 1 equal to 2 over 5 over 2 and then subtract with 0 minus 0 inside it is get only 1 over 5 over 2 and minus 1. Okay, this one is 1, this one is 1. In this term we will get a negative 2 or minus 2. Here 15 and 2 over 5 power 5 over 2 minus 2. This one we will rearrange. We will get 2 out, have the same over 15 and suppose 2 we will get square root of 2. It have the same. This one is 2 because it's divided in 2.5. Is it mean to have a 1? We will get 2. When we take it inside, it will get like this and minus 1. And this one is our answer about it. Okay, move to the next examples. You look at this. We will do like the same in the example like before. But you consider in the inside loop before, we will get it 1 4 2 1 y plus y over x dy and dx. But first we consider inside of integration, we will get 2 1 of x over y plus y over x of dx. Then I will tell you, oh sorry, this one is the integration of 2 1 x over y plus y over x respect to y. And then I tell you, the variable is just not to respect in the step. It will be a constant. And then you look at this with respect to y. This means x will get to be a constant. And how to do next? We will take the integration separately. Then x's 1 and 2 leave only 1 y dy plus 1 over x 2 and 1 of y dy. It's so easy because you look at here 1 over y will get ln y and you don't forget about it here. And then this one we will get 1 over x, and this one is y squared over 2, and the boundary is 1 to 2, and then we will move the constant out. It will like this 2x. Then you calculate ln, we will instead y to 2, we get a ln 2 and take our absolute out because it's a positive, and then negative by ln of 1. And we know ln 1 it get a 0, it leave only ln 2 plus 1 over 2x, and this one will take y equal to 2 is 4 minus 1. Here we will get it to ln 2x. We will write here, it's make you confused. Ln 2 plus this whole thing, you'll get 3 over 2x. This is the answers of inside, but it's just not just only here. We need to do inside, and we will use some space here. Outside is 1 and 4, and this one we will get x ln 2 plus 3 over 2x. And respect to x. Then if you move out all of x, because you will take the value inside when you have to integration final, then we will have to separate it again. This one constant out and 4 to 1 x dx plus integrations 3 over 2 4 and 1. This one is 1 over x dx. Okay, this one ln x, it's ln 2, and x integrate of x, we will get a x squared over 2, and then we will take this one in the 4 and 1, and then in this thing we will get 2, and 1 over x dx we will get ln x, ln absolute x, 4 and 1. Then this constant will be moved out, we will get ln 2 over 2 of inside is leave only x squared. Then we will take x to 4. 4 squared is 16 minus 1 squared is 1 plus t over 2 of ln x equal to 4 is a ln 4 minus take x to 1 is ln 1 ln 1 and ln 1 is becomes 0. It just leave what it is. But here we will take this one is a 15 ln 2 over 2 plus 3 to ln 4 equal to this one 15 ln 2 plus 3 ln 4 over 2. Yes, this is our answer that we have to do. Okay, move to the next example. This one is we call it the polar coordinate. And then the polar coordinate we will have to change to be a polar form. We will get it to double integrate this one and r d theta, and this is a polar form. And how to do with it? You will do like in the same, but we change this one and this one. First, you respect to theta, and then you respect to r. And how to do, I will show to you. Solutions to 0 to 2 integral of 0 to pi r sine square theta d theta dr. Then we consider in the inside first 0 to pi, and with respect to the theta, this means another theta will become a constant. Then we will move r out. We will get r. This one leave only this, but I will calculate just only sine c square d theta, and then you will use the trigonometry formula for theta plus cosine square theta equal to 1. Then sine square theta equal to 1 minus cosine theta square. Then you will plug in 1 minus cosine square theta d theta. You can see here, I will change the form. Then this one you will have to integrate separately. This one we will get pi and 2 and 0 of d theta minus of integration of cosine theta square d theta. And then you look at this. This one you can have to use the formula as well. We will get the formula cosine 2 theta cosine theta square will equal to 1 plus cosine 2 theta over 2. And then how we get it? We will do it. This one we will get only theta, and the bounded is 0 to pi. And this one we will do in the same, but we change 1 plus cosine 2 theta d theta, and then we will get it out because it's a constant. This one you can see theta will instead to pi and 0. Pi minus 0 is pi. Then we do next, and we will separately integrate again. 0 plus of integration of cosine 2 theta of 0 to pi d theta. This one, okay, we will get it pi minus 1 over 2 of this one is like in the same, it's just only pi plus of cosine to theta. Then you look at it like a t, and the integral of cosine is sine theta over t is true. This is the technique that you have to change that I will tell you in the how to find area in the polar coordinate before. This is a technique that you always use. You will get this one. And how to do next? We will take theta to pi and 0. You get pi minus 1 over 2 or pi plus 1 over 2. Sine 2 pi, let's get sine 2 pi we will get what is this is the angle in the 0. Cosine is x, y is sine. That means y is 0, right? And this one is 0. And the cosine 0 is just only 0. 0 minus 0 we'll get this term is 0. We will just only pi minus pi over 2. We will get pi over 2. This one, right? We will get inside is pi over 2. And then we will move in the outer integral. It's 2 and 0. And you look at this, we have r. And we get pi over 2. Pi over 2. Then with respect to r, this one is a constant. We will move out to 0. R dr. We will get pi over 2. Pi with r square over 2. 2 and 0. This one is constant. We will move out. It leaves pi over 4. This one is a 4. We will take r to be 2 and take r to be 0. This is 2 square is 4 and 0 square is 0. Then it just leaves only pi. And this is our answer. The last examples. You look at this. This one in the inside with respect to r. Okay. And this one you can see. It's just not any r inside. But we will concern it is a constant. Yes. We will take to be constant. And we do like pi over 2 is power 2 sine theta 0 dr d theta. And then you do inside is before. It's just leave only r. R. And the bounded is cosine theta and 0 is equal to cosine theta. Like this. Okay. This one will get the cosine theta. And then you plug in pi over 2 e sine theta cosine theta with respect to the theta. And then how to do next? You can see we will let some part to be u, and I try to let u equal to sine theta du cosine theta d theta, and then d theta equal to du over cosine theta, and then we will plug in the value of d theta. We will get the answer. It's just not complex in this example. This one, we let it to you. Here, we will let you to sine theta, and this one, cosine theta is just only here. But we change to du over cosine theta. This is amazing. You can cross it out. And integrations of e power to u. We will get the e to u is same as well. And the bounded of the pi over 2 and 0. And then, now in this step, in the final step, you cannot put the pi over 2 to be u. You would like to substitute u back. You let u equal to sine theta, and then you will take this one to be sine theta. You get the exponentials of sine theta pi over 2 and 0, then this one, you can see, when you take the theta equal to pi over 2, what happened? Sine pi over 2 minus e sine 0. This one is, the power is sine pi over 2 is a 1. And this one, sine 0 is, you get a 0, right? This one is e over 0 is equal to e minus, this one is 1. E minus 1. And this is our answer. Okay, this is all of the idea how to calculate in the multiple integral. I think you will understand it, and if you understand and practice yourself more, you can do it more examples and can use this idea to another example about how to find the region inside. That I think I will make the video clip for you next. If you have a question, you can ask me. Thank you very much.